Hello, everybody. It's me again, Rich Andre, and today we're going to be talking about group properties in abstract algebra. Okay, so first let's define what a group is. Okay, group is basically just a set. Okay, it's a set of numbers. If you guys can recall, a group is basically like this. It's basically just a set. Let's say you have a group of numbers like this. You can consider this a group. Okay? So, group properties, what this basically just says is that we're trying to find the properties that makes a group. Okay? So, what exactly makes a group a valid group in abstract algebra? So there are four properties that we need to consider. The first is closure. I'll just list it down. The second is associativity. Third is identity. Excuse my writing. Identity. The fourth is inverse. So you can consider something a group when it fits all of these four criteria or four properties. Okay? So let's first start with closure. Suppose we have a set of all integers with an operation of addition. Okay? Now what closure basically just means is that, okay, something, okay, if you have two elements, let's say you have two elements, whatever operation that you do on them, the result, okay, the result should be, let's say C. The result should be in the set or in the group. So in this case, okay, let's say you have, you're trying to add, in this case, let's try, you're trying to add 1 and 2. So 1 plus 2 equals 3. Is 3 a part of all integers, of all possible integers? It is. So then, this is a valid closure. And you could consider this, okay? Let's say these two, 1 and 2, a part of a set. Then you could consider this a group. You could consider this part of the group. You see? So that is what closure is. You could also do this with multiplication. Let's say this is the same thing. Now, whatever product that comes out from let's say 1 and 2 again, that product should be part of all integers. So 1 times 2 is equal to 2. Is 2 a part of all integers? Yes. And this is a valid set, a valid group. Okay? This is a valid group. Now, how about associativity? Okay, let me see if I got that if yes, associativity. It just means that whatever the order of the numbers, okay, that you're operating on is doesn't it doesn't contribute to anything. Like it doesn't matter what group or what order of the group is in when you're operating on them. So let's say you have a group of oh, excuse me. Let's say you're working with all integers again. Let's say your operation is addition. So, given that, okay, let's say you have a set 1 and 2. If you add these two, if you let's say you have no, let me just get an example, okay? So I don't get this wrong. I'll just get the example from ChatGPT here. Here. See? So let's say you have these two. Okay. Now, if you see here, okay, associativity follows this principle. Okay. So given this two sets of numbers, given 2, 3, 4, if you use this sort of general formula, you had substitute the numbers here. You have 2 plus 3. By the way, the asterisk, okay, it basically just means any operation. So it's like a placeholder for any operation. So 2 plus 3, then you add a parentheses, and the C would be 4. What's 4? Oh, sorry. Sorry about that. Whatever the number here should be equal here, and vice versa. So the order doesn't matter. The order in which you operate on them doesn't matter. If you're using PEMDAS, okay, if you're using the PEMDAS rule, and we prioritize the parentheses first, you would have 5 here plus 4, right? 5 plus 4. Then 3 plus 4 is 7 plus 2. 5 plus 4 is 9. 2 plus 7 is 9. So it doesn't matter which you prioritize in this equation. If the group is associative, and this is called additive associativity, the answer should still be equal to each other. The answer between both should be equal. Both sides should be equal with each other. If you had 3 numbers, okay, if you had 3 numbers. So that is additive associativity. How about, let's say, let's get the antithesis of this. Let's take a non-example of associativity. Let's say you're trying to subtract those 3 numbers, 2, 3, 4. Let's say you're trying to subtract them. Okay, so given the formula that we had earlier, okay, so 2 minus 3 minus 4 is equal to 2. and 3 minus 4. And you tried to operate on these two, on both sides. You had 2 minus 3, right? 2 minus 3, 1. Negative 1. Then you had negative 4 here. 3 minus 4 is negative 1. You had 2 here. So, negative 1 minus 4 is negative 5. And 2 minus 1 is 1. Now, if you could see here, these two numbers, they aren't equal to each other. So you can safely say that subtraction is not an associative. There is no such thing as a subtractive associativity. Okay, in a group when it comes to abstract algebra. But multiplication is also, let's say it's multiplication. Let's substitute the operations for multiplication. We have the 2 times 3 times 4 is equal to 2, and 3 times 4. 2 times 3, 6. Times 4, 24. 3 times 4 is 12. Times 2 is 24. So multiplication is a valid sort of associativity. So how about the third property of groups? The identity. The identity basically just says that whatever you do, okay, whatever you do onto a certain number, it always comes out as what you started with. Now, what do I mean by that? Okay, so in identities, you have A times, let's say, no. Let's say you have A in an operation E. That's going to equal to E operation A. You're going to end up with A, with what you started with. So substituting those variables with actual numbers, if you, let's say, in addition, our identity would be 0 for something to be considered a group. So if you take a certain number, let's say A is equal to 1. A is equal to 1. Now E will be 0. So A plus 1, sorry. So 1 plus 0 is equal to 1. You came back to where you started. So that is the additive identity, or the addition identity, whatever you want to call it. Multiplication, okay? Multiplication, however, okay, if you see here, let's go to the identity. For multiplication, the identity is 1. Because you come back, the principle is for identities, in group properties, when it comes to identities, the principle is you should always come back to where you started, to what the number you started with, or what the number that you operated on. So if we're taking multiplication, our identity will be 1. So let's rewrite the formula. A in some sort of operation, E equals E, some sort of operation A is equal to A. So let's say you have 1 again. Or let's change it up again. Let's say A is equal to 2. 2 times 1 is equal to 2. You came back to where you started. So the identity for multiplication is going to be 1. The identity for addition is going to be 0. So that is what identity is. That property should be considered in order for you to validate if something is a group in abstract algebra. When it comes to sets, and when it comes to groups, when it comes to integers, we're all real integers. So that's it. Now, the last property that you have to consider when you're dealing with groups in abstract algebra is the inverse. So what is the inverse? You probably know what an inverse is. Let's say you have some sort of number. Let's say you have 2 with the inverse of 1, which is 2 raised to negative 1. Now, the inverse property basically just denotes, basically just describes that the inverse should do nothing. Okay, when you operate on a certain number, let's say 2, when you operate on 2 with whatever kind of operation, the answer should be nothing. It should do nothing to the it should no, my bad. It should undo the certain number that you're operating on. So let's say, what is the inverse of 2? Okay, let's say we're doing addition, and you had let's just get a sort of example here. Let's say you have 7. Okay, now using this genetic formula, a with some sort of operation, a raised to negative 1 is equal to a negative 1, some sort of operation, a is equal to e. So now you take 7 and negative 7. Let's say you have 7 and negative 7. And then we use the addition. 7 plus negative 7 is going to be 0. So then, the inverse of 7 is equal to negative 7, which is correct. The same with multiplication or addition. Now for multiplication, the inverse, okay? If we had the inverse for addition, the inverse would be negative a. Okay, the inverse will be negative a. Meaning, if you substitute the a for any type of number, or in this case, or in that previous case, 7. Let's say 7 plus negative 7. In addition, you would get 0. So that is true for the inverse property. 7 minus 7 is equal to 0. And the principle of properties, the principle of the inverse property is that the inverse should undo the number that you're operating on. So now let's talk about multiplication inverse property. Let's say you have the inverse when it comes to multiplication is 1 over a. It's 1 over a. Why? Because if you multiply something, let's say you have 7. So let's say you have 7. 7 times 1 over 7. The 7s would cancel and you would only be left with 1. Okay? So it basically undoes itself. And it undoes itself. So the multiplication inverse is 1 over a. Okay? And that is the entirety of group properties when it comes to abstract algebra. Thank you guys for listening. See you guys in another video. Peace.